Yes, technology. It is joint work with Birger Møller Pedersen from University of Oslo. So how do I switch here like this? Well, object-oriented programming has been around for more than 50 years and is currently the dominating style of programming. And a lot of applications, as you all know, have been made with object-oriented programming. So it's clearly quite dominant, no doubt about it. Then recently, one of our colleagues referred us to a number of blog posts with these kind of headings, like object-oriented programming, the $1 trillion disaster, etc., etc. And we were quite surprised, quite shocked. What the hell is that? And he told us that we really had to comment on that. But as with all information on the web, when you start looking at it in detail, it's a lot of flawed stuff. It's not grounded in solid knowledge. There's a lot of mistakes and errors in it. So starting to argue at this kind of level seemed quite hopeless. But there's also more profound critique. Some people claim that object-oriented programming as being practiced is not really what was the intention of the founding fathers like Dahl and Nygaard and Alan Kay. And also a lot of people start saying that the era of objects is that nobody is really using it anymore, nobody is using inheritance, etc., etc. But it's very difficult actually to get your hands on the exact critique of what people is thinking about it. But of course, there's room for improvement. So an OOP is no silver bullet. So we decided that we'd use this provocation to start reflecting upon what we think could be better with objects. So it all started with Simula, which was a language for programming and modeling. And Simula was originally inspired by Horst's paper on record handling from the 60s. And if you read in that, you will see that he actually emphasized this thing that when you want to do something in a computer, you have to construct a model of that aspect of the real or conceptual world. So focus on modeling here. Richard, I should say, you mentioned that you tried to take in good invited speakers outside the area of UBSLA. And I still remember this guy who talked about the maps of imagination and about literature. And I think this was really great because it has nothing to do with programming. It was about maps and literature, but it has been a main inspiration for us regarding modeling. Our own background is that we for many years worked with especially Christian Nygaard to develop this language Beta. And Beta was also a language intended for modeling as well as programming. So we have been heavily influenced by this Simula culture, which is sort of dominating our view of the world. And the reason we think that modeling is and should be central to object-oriented programming and programming in general is that when you have an object-oriented program and you consider it a modeling perspective, you have aspects of your application domain is directly reflected in your program, and your program is thus easier to understand than if you don't consider that. And when all this stuff about object-oriented analysis design started in the 80s, Code and Yorton put it that way that we actually based it on concepts we learned in kindergarten. That may be a kind of simplification, but there's something about it. If you look at mainstream object-oriented programming, we don't see any signs of modeling at all. Now, this is perhaps This is perhaps I miss the English words, but we don't see signs of modeling in mainstream, and this is really very bad. And if you look at textbooks on object-oriented programming, they hardly mention modeling. There is this book by Barnes and Curling where they mention that you construct the model, and that's sort of all about it. And when I say mainstream, it's about how practice is applied using languages like C++, Java, C#, Python, but also Smalltalk and other languages. And you read the Smalltalk book, you see no mentioning of modeling at all there. And the same with most research papers on object-oriented programming. It's very technical, it's about type theory, it's very, very little about modeling. So our main message in the paper is that there has been too much focus on code reuse in object-oriented programming and too little focus on modeling. So our recommendation is that one starts reintroducing modeling as the main benefit of object-oriented programming. And this is sort of what we will go through here. And clearly, if you look at mainstream, reuse is considered the main advantage of object-oriented programming by most authors. And of course, object-oriented languages provided new mechanisms for reuse, class, subclass, inheritance, virtues, etc. But the downside is that modeling was sort of fading away. And we often hear that real programmers do not model. And this thing about inheritance as a reuse thing, you may trace it back to a very influential paper by Wegner and Sedonic called Inheritance as an Incremental Modification Technique. And I should say that these people here, which we may disagree with, they are all or have all been good friends that we have enjoyed working with for many years, but we really disagree with them. Wegner was a long-term friend, and we learned this morning that we lost William Cook last year. And but he and I has had lots of discussions on modeling, etc., etc. But this quote here is from the paper he wrote at a special anniversary second session at ECOP. And then Andrew Black recently wrote for the similar anniversary that he thinks that code reuse like inheritance is very, very important. Now, Andrew Black is my favorite person to argue with. We seem to disagree about almost everything. So hopefully some of you will take his point of view here today. But there's no yes or no or black or white here. It's all a matter of your perspective on things. What we have been trying to do is identify what we consider a number of problematic issues of mainstream object-oriented programming. And as I said, it's a subjective analysis, so no yes or no here. So a main message is that by focusing solely on reuse, the benefit of modeling is lost or has been lost. One problem with mainstream is this notion of implementation inheritance, where people take a class, they make a subclass, they redefine whatever they think needs to be redefined, and then they have some new code. So a lazy way of reusing stuff and redefining what you don't really need. And one standard example is this definition of a class stack that simply inherits from a class vector. Because then you have most of the functionality you need, and it's very simple to make the stack. But the problem here is that there's no conceptual relation between a stack and a vector. A stack is not a specialization of a vector. When you use subclasses, you should be sure that your subclasses are all specializations of their superclasses. If you don't do that, you will have a hierarchy of classes with no conceptual relations other than a real use relation. You have class hierarchies that may be difficult to maintain and navigate. And worst of all is that if you may have a subclass which is not sort of compatible with its superclass. So one of the nice things about object-oriented programming is that an instance of a superclass should be able to be used at any point of its superclasses. But this may all be destroyed if you use solely implementation inheritance. And as I said, the benefit of modeling is that the program reflects the domain. The program is a description of a model of the relevant aspects of the domain. And such descriptions are good for communication, also among others than programmers. And it's much easier to understand a program if it's really reflecting your application domain. Another issue is this business about virtual and non-virtual methods. In Simula, you distinguish virtual and non-virtual methods. And just to make it short, in Smalltalk and Java, all methods are virtual. And from a reuse point of view, this provides maximum flexibility, of course. But the problem is that it's not possible to express that some behavior of a class is the same for all subclasses. And for a user, it's not at all obvious which methods that needs to be redefined in a subclass. You may use these keywords final and sealed in Java and C# to fix some of this. But in general, when virtuals are default, most methods are in practice virtual. And virtual procedures in Algol were introduced as a replacement for name parameters and formal parameters. And if all methods are virtual, they are in fact all potential parameters. I did mention this paper by Wegner and Sedonic on incremental modification. And Black, Bruce, and this gentleman sitting down there actually considered inheritance as a mechanism for starting with a concrete bait and later abstracting over concrete elements and sort of be able to redefine everything. And they call this ex post facto parameterization. I'm sure I can be corrected if I'm wrong here. But I think the problem with this way to go is that the interface to a superclass is not well specified, and it's not clear at all which kind of methods to redefine in a subclass. And also I think there is some Mac PC problem here, that when you redefine a virtual method, you really need to make sure that the redefinition extends the definition of the one in the superclass. Because you have to make sure that, oh sorry, that was too quickly, that all possible class invariants, pre and post conditions of the method being redefined are also fulfilled in the subclass. So just don't redefine stuff. Now, I mentioned that some people say that OO as practice is not what Alan Kay had in mind. And there is an interview out there where he said that object-oriented programming is a set of objects sending messages to another, and this stuff about subclasses, etc., was just something somebody at Park Place added without he really knowing. So, but we don't think there's any conflict here, and would like to mention that for Simula, it was essential to be able to model processes as well as objects with data and methods. So still, if you look at Simula, a class may have a statement part, and it actually behave like a coroutine, and it may behave like a concurrent process. So objects are in Simula actually active. And no one of the mainstream object-oriented languages has taken this over. Smalltalk objects are not active objects because they are just receiving messages, but Simula objects are active. So I think this is one of the things that mainstream languages could still learn from Simula, even if it's many, many years ago. One of our main messages is that we consider programming as modeling. And I hear very little also so far at this conference about programming as modeling. So our claim is that it's necessary that programmers must learn to model, and this should be taught as an integrated discipline together with programming. And as I mentioned, this is not the case with most teaching and books on object-oriented programming. For the beta language, we actually developed what we call a conceptual framework for organizing and understanding knowledge about application domains. And this sort of includes a definition of what is really an object-oriented model, something about how do we understand phenomena and concepts from the application domain, and something about teaching people about conceptual means such like classification, composition, context, association. Starting with a model, there is some disagreement about what is really an object-oriented model, but in our interpretation, it's the program execution that is the model. So if you have an application domain here with a lot of vehicles, cars, buses, and trucks, then the model is the program execution with the objects representing cars, buses, and trucks. And the program is a description of the model. The program is not the model. The description could also be a UML diagram. And the UML community consider the diagram to be the model. If you look at a Lego toy for building a model of this Mini, then you will consider the Lego model, the Lego car, the model, and not the instruction set for constructing the model. The instruction set is like the program. It's a description, a prescription of how to actually build the model. And we think this is very important to be aware of, that it's sort of the dynamic stuff in the computer that is really the model. So my car here may be a representation of the Mini, and I may have a UML diagram or a programming language description of the model, actually. I mentioned that people should have some common understanding of what kind of phenomena do they actually meet in an application domain. If you look at these vehicles here, you can see each single car is what we call a physical phenomena. It's actually some substance, some material. And the weight and license number of a car are properties of these physical phenomena. And the car trip from home to work is an example of another kind of phenomenon, namely, which is a transformation that changes the state, the properties of the cars. This is a very, very, very short way of presenting this stuff, but it's kind of the thing that we think programmers need to know about. Similarly, for concepts, people should have some idea about what is a concept, and be aware of examples of domain concepts when they build their models or programs or whatever. Then I mentioned this thing about conceptual means for understanding and organizing knowledge, classification, which is about organizing phenomena and concepts in hierarchies, composition, understanding the structure of physical objects as part of wholes, context, understanding the context of phenomena and concepts, and associations, which are sort of relations between phenomena. If you learn about classical concepts, you will learn that a concept is characterized by an extension, which is the phenomena that are covered by the concept. And here for vehicle, we have that the extension of the concept of vehicle are all vehicles. The intension of a concept is the properties of the phenomena covered by the concepts. And concepts may be organized in these generalization, specialization hierarchies. And if you look at the extension of a specialized concept like the bus, then this is a subset of the extension of the generalized concept. But the intention of the specialized concept sort of extends the intention of the corresponding generalized concept by adding additional properties. This may explain why people sometimes talk about subclasses, because this goes for the extension. And in Java, you say extend. This sort of goes for extending the intention. And of course, classes may represent concepts. Subclasses may represent specializations, and they should represent specializations. And class hierarchies may represent classification hierarchies, etc. And the essence here is that properties specified in a class are inherited, sort of imposed on subclasses. I have no idea about time here.
We've got 20 minutes left, but we'd like to leave some time for questions.
Good, good. A final issue about multiple inheritance and classification. It may not be that big deal anymore to discuss multiple inheritance, but it's really something which is very, very complicated. And here we recommend that people learn about properties of classifications hierarchies, because we know about these tree-structured classification hierarchies. We also know about non-tree structured classification hierarchies, which is what a multiple inheritance often give you. But also there is a situation where you have several independent classification hierarchies. And also you may have classifications where objects change class membership over time. And finally, you should also consider classification of actions. In beta, we actually are able to express that a method may inherit from another method, so you can have hierarchies of methods and processes. And as an example of an independent classification hierarchies, you may think of something like this, where you can want to classify people according to their profession or according to their nationality, which are two sort of independent classification hierarchies. But if you use multiple inheritance just under your arm, you may end up with subclasses like an European teacher or an Oceanian nurse or whatever, lots of combinations. I know that there are no real languages that support this kind of classification, but at least it's good to teach it, that there are these kind of classification hierarchies, and students or programmers should be aware when they sort of meet the limitations of their programming language. Now, I said modeling is not really present in object-oriented programming, and people may ask about the modeling community. It was actually quite good when people like Coden, Jordan, Rombaugh, Booth, and others started presenting ideas about object-oriented modeling in the 80s. And the real good thing about it was that it sort of replaced this thing called structural analysis and structured design, which was sort of the main techniques for program development. Some of the people here may remember it. I think that most of you don't have an age where you remember this stuff. So you could actually use sort of the same approach through all development phases. The bad thing here is that, at least from our point of view, it seems that modeling and programming communities became two disjoint communities. Many programmers don't make UML models, and many modelers don't make programs. Sometimes you have projects that start designing with UML, creating UML diagrams, but they are often left behind when the projects go ahead because it's too expensive to keep the UML model up to date. So this, in our opinion, it does not really work. But we think that you don't have to use UML for real to be modeling. You may use your favorite object-oriented language to describe your models. So if you don't have a UML tool or other things, I think it was mentioned this morning that there's very little connection between UML and tools and the actual programming languages. So you can use your favorite language Some people prefer graphics, and some prefer diagrams. Some prefer diagrams because they are good for communication, and that is true. But you can easily draw diagrams without drawing a UML tool. It's fine to use it if you have it. But also be aware that a textual representation of a UML diagram has just as much information as the UML diagram. And actually, for the beta language, we developed two kinds of syntax for beta. There was a textual representation and there was a diagrammatic representation. And the editor could alternate between showing both kinds of representations. And you can edit the diagrams and it's reflected in the text or vice versa. This of course means that there needs to be a one-to-one correspondence between your program text and the diagrams. And this is one of the problems with UML and most programming languages. So, yeah, but you don't have to use UML to do modeling. So, yes, not too much more to say here, but our main message is we think there's too much focus on reuse, and programming is modeling, and programmers should be more explicit about modeling, and so should researchers. Thank you.
Thank you. Well, we've got about 10 minutes for questions and discussion. Excellent, please.
I'm afraid that I'm an old guy too.
Singular.
Yes. Once in this one, I was approached by Tony Hoare, and I was very disappointed when he said, "Oh, I was attracted by your Singular T-shirt." But about structured versus object-oriented. Once I asked Christian Nietzsche, how come that you invented object orientation at a time when for everybody else structured was the catchword? He said, you correct me. No, you are wrong. At that time, the catchword structured hasn't been invented yet. So object is really it's older. But a more serious question. You said it's regrettable that current textbooks don't deal with modeling so much. As far as simulation is concerned,
yes,
we had SimSet in simulation.
Sure.
Similar was ready for
Sure.
simulation,
Yeah.
and perhaps things like that should be developed first in most other languages. For instance, many years ago, there was a presentation about an ADA package transit with a similar functionality of simulation. So that's of course also a hurdle when it comes to modeling.
Yes, clearly the simulation community has a long tradition in creating models because that's the whole purpose of simulation. So, yes.
Can you summarize? Yes, the people online can't really hear the questions. You're going to have to maybe stand close to the microphone, sorry.
Okay.
Sort of summarize the discussion, if that's okay. Thank you.
Yeah. So, should I summarize? Well,
Please.
Well, this gentleman there actually said he was also an old guy, and he has a similar T-shirt, and I understand that he comes from the simulation community, where they have a long tradition for building models, and this was clearly the original background for developing Simula, that they needed a language to be able to describe models of the real world. And they have had a huge impact on the Simula programming language so far. So, and you also asked Christian Nygaard why
he invented object orientation at a time when everybody else talked about structure.
Yes. Nygaard, they invented object orientation when everybody talked about structured programming. But apparently Nygaard said structured programming wasn't invented when they invented Simula. That was in the early 70s. Yeah.
Yeah, so I totally agree that there's too much focus on reuse in OOP, and I think that these days we really, implementation and reuse is not the right thing. But I want to ask about programming as modeling, and at some level I agree, but also if I'm trying to teach first year programming, which I haven't actually done, then like I feel lame saying like, here's this vehicle, there's this hierarchy bus. And like, this is not what people actually do when they program, right? You are never going to actually program vehicle, bus, train, or whatever, right? It's just not a realistic example.
You know, my hearing is not always that good, so you say you're not always programming vehicles or things like that. You mean real world stuff or?
Yeah, the examples we give when we talk about object-oriented programming,
Yeah.
they're realistic examples in some sense, but they're not realistic programming examples, right? You wouldn't program it that way.
Yeah. But I think, we think our claim is that you may apply modeling to any domain. It would maybe as well be a technical domain with buffers and producers and consumers.
Yes.
Because in any domain, there are some phenomena, there are some concepts, and you may create a model of that stuff. It does not have to be about real world examples like cars and registrations, etc. So any domain.
Maybe when we talk to first year students, we should have examples that are more realistic in the sense of things that you might actually program as opposed to poor analogies of the real world.
Sure. I think we need both actually.
Yeah, probably both.
Because when we wrote about the beta language once, they were teaching some students at the humanities how to program. And they asked us to throw out all of the computer science examples like stacks, cubes, and this.
Yes.
And then give some real world examples. But sure, there also needs to be the other kind of examples.
Yeah, analogies are always dangerous because they can lead you to bad places.
Yes, really enjoyed your talk. This is an area close to my heart as I wrote an essay 9 years ago on the benefits of object-oriented programming.
Okay.
I drew a lot of inspiration from Kay's message passing model and focused on the benefits of interoperable extensions in that work. But I really think, I'm really glad you wrote your essay because I was trying to focus on one thing, I didn't focus on modeling. And I think this is super important. And I will say, you mentioned education. Carnegie Mellon, we do, when we teach object-oriented programming, we actually spend more time on modeling than on reuse.
Okay.
I think it's really important. We give students critiques on their models before they implement them.
Okay.
I think it's hard to make an argument because it's sometimes because it's all about, as you said, the human act, modeling is a human act. But I think it's nevertheless very important. I don't know if you have a way of, I don't know if you have thoughts on like how to make more concrete this argument about, which is so based on, kind of conceptual issues.
And when we teach this conceptual framework, which I just touched upon, most students seem to like it and to be able to apply it to their real world examples. But I should also say that in the world I come from, when we develop systems, we have a tradition for a huge involvement of users, end users, this thing often called participatory design. And there was this discussions about specifications, formal specifications. Most systems we develop are involving end users. You often start by having anthropologists studying a work domain, finding out what's going on, and then a lot of prototypes are developed in short cycles. And the users are involved in all of these cycles from beginning to end, and the prototypes are tested in the environment. And then the object-oriented models. This case tool I showed you here, we actually, when we talked to the users, we showed them the diagrams. But the programmers didn't want to look at these diagrams because they take up too much space. They want the more compact thing. So being able to involve users closely and present these models and have them validate that this is actually a description of their domain, that I think is very important, because it is hard to connect programs with the real world, because this is really what semantics is about. it's more easy not to, what should I say, it's easier to make a semantics in terms of some mathematics, because it's a format from one formal system to another that have your semantics representing stuff from the real world. There's no way you can physically do anything about that. That's very difficult.
I love that point. I'm going to make it in my class this year.
I know that the computational thinking movement emphasizes modeling as a skill to teach to beginners, that perhaps they don't have the object-oriented tool set to do that effectively. There's a question over there at the back somewhere. Yes, please stand and shout.
Hi, yeah, my question was about algebraic effects, actually. So I know that's not very closely related to OO, but maybe it is. That's what my question is going to be about. So you say that we're supposed to focus on modeling, and so a hot topic at the moment in programming languages is algebraic effects.
Yeah.
What that is all about is about essentially programming against an interface. As I understand, you give a nice definition of modeling here. I think a part of it was that you should be programming against an interface. So I guess my question is, perhaps a point for discussion, is algebraic effects object-oriented programming?
That's you can answer yes or no, but I would say you can approach it using object-oriented programming. I have not that much experience with algebraic effect, but obviously you should be able to do it with object-oriented programming and represent your environment in your program. And some kind of related thing is this business about digital twins. When you work with digital twins, this is where you have a real physical system, and you create a consumer model object, which could also be an object-oriented model that is sort of also connected to your real physical world. So I would think that it's an obvious thing to be able to do in object-oriented models. And then you go, sorry, I forget to start.
Well, I'm going to invite you in the last minute just to summarize your thoughts and the discussion, and then we'll conclude. Thank you.
I will say, as Richard, I'm not that good at summarizing. At least I did not get shot here. So, but everybody has just seen this, what do you call it, way of behavior that we were told about this morning, no threats or whatever. So, but I hear that most people seem to agree that modeling should play a bigger role than it has. So that's sort of good to hear. So,
thank you.